Today we're looking at section 6.1, solving one-step linear inequalities. We got a couple of goals. First one is to graph linear inequalities in one variable, and our second one is to solve one-step linear inequalities. We're beginning on page 334. Got a couple of definitions. First off, the graph of a linear inequality in one variable is a set of points on a number line that represents all solutions of the inequality. So an example of that one would be x is less than 3, and then a graph of it would look something like this with a 0, 3 here. Less than would be an open circle and everything that's smaller than 3. Equivalent inequalities are inequalities that have the same solution. X is less than 3 is equivalent to 3 is greater than x. Those are equivalent. Notice they're written backwards, but they mean the exact same thing, where the point is pointing to the smaller number. Notice the point's pointing to x on both of them, and the bigger mouth is eating the bigger number on them. It's eating 3 for both of them. Example number one is writing graph of linear equality. The speed limit, you're traveling in a section of town where the speed limit is 35 miles per hour. Writing inequality to describe the speeds that are over the speed limit in that section, and then graph the inequality. Speeds greater than 35 miles an hour are against the law. So greater than would go in that first blank, because you can go 35 miles an hour and not get a ticket, but technically 36 miles an hour would get you a ticket. Let S represent speeds that are over the speed limit. So your inequality, so speeds that are over, would go in that next blank, and your inequality would be S is greater than 35. Again, where the point goes to the 35. S is greater than 35 would be an open circle and everything to the right of it. An open circle is the same thing as a parentheses. If you ever see a parentheses, it means the same thing. A closed circle, which we'll look at in a couple minutes, is the same thing as a bracket. If you ever see a bracket, it means to include the number. If you ever see a parentheses, it means to not include that number, in this case, like 35. Just a little reminder right here. It says, remember, an open dot's used for less than or greater than, and a solid dot's used for greater than and less than or equal to for both of them. The first checkpoint says you must be 18 years or older to vote in the town election. Write an inequality to describe the ages of people allowed to vote in the town election, then graph the inequality. You can be 18 years old to vote. So you have X is greater than or equal to 18, because you can be 18. So 18 and older. And as you graph that, you would be a closed circle and everything to the right of it, since it's greater than. Your transformations, most of these are very simple and they act just like equations. The last two are a little different. The first one says x minus 3 is less than 5. You add the same number to each side. In this case, we're adding 3 to both sides. And 5 plus 3 will give you x is less than 8. For the second one, it says subtract the same number from each side. X plus 6 is greater than or equal to 9. Subtract 6 on both sides. And then 9 minus 6 is 3, so x is greater than or equal to 3. Next one says multiply each side by the same. In that blanket, it'll say positive number. 1 over 2 times x is the same thing as 1x over 2 divided by 3. Get rid of divide by 2 by multiplying both sides by 2. That'll cancel this out and just leave you with x is greater than 6. Next one says divide each side by the same positive number. Again, 3 times x. You undo that by dividing by 3. If you do it on the right, you got left, you got to do it on the right. X is less than or equal to 3. Okay, and then this is the part, the next part are the two that are different. When it says multiply each side by the same, that blank has to say negative number and reverse the inequality symbol. So negative 1 times x, you multiply by negative 1. You multiply both of them by negative 1. When you're multiplying by a negative 1, it'll cancel this out and leave you with x. And 4 times negative 1 will be a negative 4. But since you're multiplying by a negative 1, you have to reverse the symbol from less than to greater than. So x is greater than negative 4. The last one's probably the easier one to see. When you're dividing by the same negative number, you have to reverse the inequality symbol. So negative 2 times x, you divide by negative 2, and you do the same thing on the right, And x, 6 divided by 2 is -3. Less than or equal to becomes greater than or equal to. You have to flip that symbol. Anytime you're dividing by a negative number, you flip the symbol. Example number 2 says solve x plus y is less than or equal to 7 and then graph it. Get rid of plus, I said x plus y, I meant x plus 11. Get rid of plus 11 by subtracting 11 on both sides, and that's the step here, subtracting 11. Um, and then you have x is less than or equal to -4. Notice the symbol stays the same, less than or equal to. So the solution is all real numbers that are less than or equal to -4. And as you graph it, it's a closed-end dot or closed-end bubble and everything that's less than. A way for you to check, if you notice that little bubble on the side, says check possible solutions by substituting in the original inequality and see if it's true. If it's true, then it satisfies it. If not, then it doesn't. So just say we use an -10. If you plug them in, uh, x plus 11 is less than or equal to 7 becomes 10 plus 11 is less than or equal, I'm sorry, -10. Not, that's what I was saying. It's not +10. It's -10 plus 11 is less than or equal to 7. This is 1 is less than or equal to 7. That's a true statement. That's how you can check it. Example number 3 says b over 5 is greater than or equal to 12, or b divided by 5. You get rid of that by you multiply both sides by 5. This will cancel out and leave you with b is greater than or equal to 60. Notice you don't change the symbol, greater than or equal to. When you graph that, it would be a closed-end dot, or again, it'd be a bracket if you used one, and everything that's larger than closed-end dot. Example number 4 says -1.8n is less than -1.5. -1.8 times n, you divide by -1.8. If you do divide by -1.8 on the left, you got to divide by -1.8 on the right, and you'll get 2.5. But since you divided by a negative number, less than becomes greater than. N is greater than 2.5. You had to reverse the symbol. So greater than 2.5, notice it's not or equal to, it's an open circle, and everything that's larger than 2.5. Your checkpoints say x minus 4 is greater than -13. Get rid of -4 by adding 4 on both sides. So x minus 4 is greater than -13. Add 4 on both sides. Your symbol stays the same since you didn't multiply or divide by a negative number. These will cancel. X is greater than -9. That's what we have here. Greater than -9 will be an open circle, and everything that's larger than -9. And then -10y is greater than or equal to 50. Get rid of -10 times y by dividing by -10 on both sides. And then y, 50 divided by -10 is -5, but we divided by a negative number, so greater than or equal becomes less than or equal to -5. Less than or equal, it's a closed-end dot, and everything that's smaller than that.